Hey Kylie. So at our last session, I believe that we learned the substitution method. If that's not true, then you can pause this video and you can kind of copy down these notes. I'm still going to be going through them and explaining, but I'm pretty sure that this is from our last session together. But we are going to be continuing on with the substitution method. So on the next page, we have some more difficult substitution problems because they're not ready for substitution. So in order for substitution to work, one equation has to look like this. Either x equals whatever or y equals whatever. So once we look at number 5, we don't have that situation. We have 2x plus y equals -2 and 5x plus 3y equals -8. So neither one of these equations we have x equals or y equals. So substitution cannot work in this situation. So what we have to do is decide, should we solve for this x? Should we solve for this x? Should we solve for this y or solve for this y? The easiest variable to solve for is going to be a single x or a single y. Is going to be anything that looks like this, like 3x plus y equals 10. Y would be an easy variable to solve for. Or maybe it says like x minus 2y equals 8. I'm just making these up. That would be super simple to solve for. Why? Because anytime you have a single variable, 1y or 1x, you will not have to divide. So even though you will have to move things to the other side, you'll never have to divide by a number, which it's fine to have to divide, but sometimes it would incorporate fractions. For example, for number 5, if I decided to solve for, let's say, 2x plus y equals -2, so I'm choosing to solve the first equation for x, I would have to subtract y from both sides. I would get 2x equals -2 minus y, or -y minus 2. And then when I divide everything by 2, I'm going to get -1 here, which is fine. But then I'm going to get -1/2 y. And that's just a fraction that I don't feel like dealing with, because then when I go to take that stuff and put it in for x, I'm just going to have fractions along the way, and it's just not worth it, honestly. If there's an easier way to go about a math problem, we should always try to do that. The easiest variable to solve for is the first y in the equation, and that's because if I wanted to take the equation 2x plus y equals -2 and solve it for y, all I'd have to do is subtract both sides by 2x. No division is needed. So I would get y equals -2x minus 2, and then I have exactly what I need. I need one equation to either say x equals or y equals, and now I have one equation that says y equals. Y is equal to -2x minus 2. Substitution can begin. I use the other equation that I did not just rewrite. So I have to use this equation, 5x plus 3y equals -8, and I'm going to replace -2x minus 2 in for y right there. So it's going to look like this. 5x plus 3 times -2x minus 2 equals -8. So now it's just like a solving game. We're going to distribute. So it'll look up here. I'll finish up here. 5x. 3 times -2x is -6x. 3 times -2 is -6. So here's what we have. Combine like terms. This is going to be -1x. And then solve it out. Add 6 to both sides. I get -x equals -2. Divide by -1. And I get x equals 2. So we definitely know that these two lines intersect at 2, comma. Now we have to figure out y. We can go back to the original equation and select either this equation or this equation. But this one is always going to be the one that we rewrote is always going to be the easiest one to use once we found x. So that's the one I'm going to use. Y equals -2x minus 2. We'll replace what we just found x to be, which is 2. and then solve it out. Negative 2 times 2 is negative 4. Negative 4 minus 2 more is negative 6. So the final answer would be 2 comma negative 6. Okay, so for each one of these questions, it's going to be more difficult because we have to solve for a variable first before we can begin the process. Number 6. So 2x minus 3y equals negative 11. I don't like either one of those variables. But in the second equation, this one, super easy to solve for. Just subtract both sides by 2x. Then I get y equals negative 2x plus 9. Oops. And substitution can begin. So what I'm going to do is take negative 2x plus 9, which is equal to y, and replace it in for y in the first equation this time. So it's going to look like this. 2x minus 3 times y, which I'm going to substitute in negative 2x plus 9, and then that will equal negative 11. Alrighty, so now for the simplification and the distributive property, combining like terms, all that kind of stuff, I'm going to get 2x, and then negative 3 times negative 2x is positive 6x. Negative 3 times 9 is negative 27. 2x plus 6x is 8x. I'm now going to add 27 to both sides. Negative 11 plus 27 is 16. Dividing by 8, and I get x equals 2. Perfect. Y is going to be equal to, let's use this one, negative 2x plus 9. Replace in a 2 for x. Negative 4 plus 9 is 5. So altogether, the final answer would be 2 comma 5. Now, sometimes it's going to feel a little uncomfortable because the easiest variable to solve for is not y. It's kind of natural for us to solve for y because when we're graphing, we solve for y. You know, the first thing I ever taught you guys when it was like learning about literal equations, I was like, take this equation and solve for y. But like in number 7, the easiest variable to solve for if we're looking at all the options, 1x, 5y, 3x, 15y, is definitely not y. It's going to be the first x. So it's just weird solving for x because we're just not used to it. But if we take the first equation, x plus 5y equals 4, and we solve this for x, we would get x equals negative 5y plus 4, or 4 minus 5y. Honestly, does not matter the order you put it in. I'm just going to put the y first, negative 5y plus 4. Then I take that, and I replace it in for x, not in the first equation. I can't use this one because that's the one I just rewrote. You have to use the other equation. So I'm going to take that and I'm going to replace it in for x in the second equation. It's going to look like this. 3 times what x is, which is negative 5y plus 4, and then plus 15y equals negative 1. Okay. Once I go through that, now I'm just going to simplify. So this is going to be negative 15y plus 12 plus 15y equals negative 1. And this is an interesting situation. When I go to combine like terms and I combine my y's like I normally would in another problem, all of the y's cancel out. Negative 15y plus 15y is nothing. So they all go away, and we're left with a 12 on the left-hand side of the equal sign, and we're left with a negative 1 on the right-hand side. So because that's not true, we have a number 12 that's not equal to another number, negative 1. Because this is false, algebraically, we just solved this system and we realized that there's actually no solution. So graphically, no solution systems of equations are parallel lines. So when we go to graph them, we're like, okay, that makes sense. They never actually cross, so how could we find an intersection point? There's no solution. But algebraically, when we go to solve it, this is what would happen. Everything cancels out, and well, variable-wise, and you're left with numbers that don't equal each other. So when that happens, we automatically know that this system actually has no answer. And it has no answer because these two lines are parallel. So if we were to solve both of them for y, we would see they have the same slope and a different y-intercept. Okay, but moving on, number 8, looking at the system of equations and deciding which variable is best is super important. Definitely the first x here would be the easiest to solve for. So x plus 4y equals 0. I'm going to solve this for x. And 0 minus 4y is just negative 4y. So like I don't necessarily need the 0. I'm going to now take negative 4y and replace it in for x right here. So 3 times x plus 2 times y equals 20 is the equation. And I'm replacing in for x a negative 4y and solving it out. So negative 12y is what I would get here, which negative 12y plus 2y is negative 10y. Divide by negative 10, and I get y equals negative 2. Now that I have y, I know that x is equal to negative 4 times whatever y is. Negative 4 times negative 2 is 8. That was actually a pretty quick one. This one's going to be 8, negative 2 as my final answer. Okay, let's do number 3. So number 9. So number 9, we have 6x plus 3y equals 54 and 2x plus y equals 18. Out of these options, this one definitely is the easiest to solve for. I get y equals negative 2x plus 18. Then I'm going to take this stuff and I'm going to replace it in for y in the other equation. So it's going to be 6x plus 3y equals 54 to start, but I'm substituting in negative 2x plus 18 in for y. Now for the distributive property. So when I multiply 3 times negative 2x, I get negative 6x. 3 times 18 is 54. So I get a kind of a weird equation here because 6x minus 6x cancels. And I'm left with two numbers, 54 equals 54. Because this is a true statement, everything canceled out. This actually means there's infinite solutions. These are the same exact lines. If we actually solved both of these for y, we would get the same exact thing. And honestly, maybe you were able to kind of see like 2x plus y equals 18. If you multiply all of these things by 3, it turns into the exact same equation here. 6x plus 3y equals 54. They're the same exact line. So they cross at every single point. So we saw questions that worked out to be regular answers like x equals 2, y equals 5. We saw a no solution question. We saw an infinite solution question. We saw the questions that started out easier where you could already start with substitution right from the start. We did that last week. And now we can see how to do the more difficult problems where we have to choose a variable to solve for first, solve for it, and then use that for substitution. So to practice this, my suggestion is, we'll come back to this because I think that that's a good idea to do, to work through these problems would be this page in our packet, homework 2. Just give me a second here to just erase this. So this is a good practice because this is going to give you just more practice problems, some of which are easy, some of which are going to be a little bit more difficult. And I do want you to practice like both types, ones that are a little bit easier and difficult. So instead of doing all 16, which I feel like is too much, why don't you do just the odds? So let's do like 1, 3, 5, 7 on that page, and then 9, 11, 13, and 15. So for numbers 1, 3, 5, and 7 on the first page here. So if we're looking at the first page is going to be the easier page because these ones are already solved for x or y. Like number 1, y equals 3x plus 19. So we can take 3x plus 19 and replace it right in for that y there and then solve for x. That one's ready to go. Same with number 3. y equals x plus 8, so we just take x plus 8 and replace it in for y in the other equation. It's ready to go. So 5 and 7 are going to kind of be like that too. But once we move on to the next page, this is like what I just covered. You have to go through, since we don't have any y equals or x equals, you have to go through and decide, should I solve for that x, this y, this x, or this y, which I would suggest solving for this y first. Take that, and then you can do the substitution step. So how about you try those problems, and then when you finish with that, you can send me a picture and I can check your work and send you a little video back. I hope you feel better soon. We'll be in touch through email.